What is it? What is it? I don't want to be in the video. I don't want to be in the video. I don't do that. I do that live for some reason.
Yeah, he does.
All right, so homework should be out. I'll come out and give it a quick mark.
Why did you do the test? So ready.
When this is a fraction,
This is worth it.
or I could just give you nothing. Do you remember all those change?
All right, we all good? Did everyone get some sort of mark? I didn't mark you.
67.
Bless you.
Oh, yeah, that was your
Okay.
source.
Here we go.
Yeah, they're called rib cage.
So there was B, right? Worksheet B. Okay, let's take a look at that front page. What kind of questions did we come across? Go ahead. 10, okay. Number 10. Is that the one? Okay. So the directions say on number 10, simplify, assume all variables are positive, and then they give a disclaimer that your variable in the denominator is not 0. Is that okay? Okay, so the 3/4 power, if you think about this, is the same thing as the 4th root, and then the whole thing to the 3rd. Is that okay so far? So let's see if we can start dealing with the stuff. I'm going to leave this outside for now. We're going to take the 4th root of 81, so that's going to be 3, and then that has to be to the 3rd. And then the 4th root of this, well, now I'm going to incorporate this in here, and I'm going to say the 4th root of x to the 9th. Let me just pause there for a minute because I know it looks way confusing what I did. Okay, so first off, is everybody okay with the 4th root of 81 being 3? Okay. So realize you can do the cubic. You can go 81 to the 3rd and then take the 4th root, which is ridiculous. Or you can do the 4th root of 81 and then raise it to the 3rd. So I use that outside. I took care of doing the 4th root here on this first. That was taken care of first, so that comes down to this. Okay? But then I went kind of the opposite way. I said, hey, I'm going to bring this to multiply here to get to the 9th, and then I have 4th root of that on bottom.
So then it would be x squared.
So now, so what I'm looking for is so think of this. 4th root of x to the 9th. It's all those x's multiplied together. Thank goodness we only stopped at 9. So how many of a kind am I looking for?
4.
So what is the 4th root of that? Just x, so an x is outside. What's the 4th root of that? X. So there's another x outside, and then I'm left with this. So that's going to give me x squared, 4th root of x. That's what my denominator is going to be. So now I'm going to replace it. So 3 times 3 times 3 is 27. X squared, 4th root of x. And it's supposed to make your mind go,
Well, so is it just easier if you set the whole thing up as a big fraction?
Oh, could, yeah. And I'm saying it could because there's different ways that you can approach it, especially because the outside exponent and the radical is the exact same hierarchy of power that math has. So it doesn't matter if you do this one first or this one, or making fractions and go from there. There's all kinds of incredible ways to do these. What else do we see from that front page? Go ahead, Mia. 11. So that's basically saying the fifth root of something, right? Do you agree? Okay, so let's think about 32. 2, 4, 8, 16, 32. So what's the fifth root of 32? 2. And then I'm going to do what to that 2? To the third, which takes it back to 8. So on top I get an 8. I'm just going to pause. I'm not done yet. Everyone follow what I just did. I realized that 32 is a perfect fifth root because 2, 4, 8, 16, 32. So it's 2 to the fifth. So if I take the fifth root of 2 to the fifth, I get 2. And then I have 2 to the third power, and that's 2 times 2 times 2, which is 8. Are we okay with the numerator? And then the denominator, basically I'm just going to multiply these together. Those are my exponents, so I'm going to get 18 over 5. So on the bottom I'm going to get that, which kind of nasty, ugly. Whenever you use that in life, I get, man, you're right, you're not. What else from that front page? Yeah. 6? Is that what you said? I'm not even going to write the z to the 0 because z to the 0 is 1, right? Is it okay if I don't worry about writing that there? Yeah. Everyone good with that so far?
What about the z? Oh, I see. I thought you were just like getting rid of it for a second, but I see.
Z to the 0 is 1. It would just be brought up front. Okay. We can hang on to the negative exponent for right now. So that 4/5 is going to get multiplied here. So I have negative 20 times 4 over 5. Sure what that is? That's going to give me negative 4, so I get negative 16. I get x to the negative 16, so that's going to move down. And then I have 4 over 5 times 3 over 4. Those cancel, so I get y to the 3/5. So that's almost done, but I don't want to have a negative in the numerator. I don't want a negative exponent at all, so I'm going to move the x to the 16 down. Yeah, that would just be a 1 that would end up there, and then technically I could put the 1 right there. Because 0 times 4/5 is still 0. Right? Okay, let's flip it over, take a look at the second side. And there might be some questions there that we can deal with. Yeah. 2/5? Number 25. We got negative 5, and then I have the third root of negative 24. Is that the one? Cool. Okay. So I have to look at this and start realizing, one, I can have a third root of a negative number because it will exist. And then 24 is not a perfect cube, but 8 is. And 8 times what gives me 24? 3. So I'm going to change this to negative 5, third root of negative 8 times 3. Is that okay? What is the third root of negative 8? Negative 2. So I'm bringing a negative 2 outside, multiplying it with the negative 10, or negative 5, so I get 10. And then I'm left with third root of 3. Yeah. 35. assume that is a plus. Are you seeing that as a plus? Okay. I'm going to drop the parentheses because I can. They weren't necessary for the problem itself. Okay. So I cannot add these together as they sit because they appear to be unlike terms. So I am going to, I think I could recognize that 16 is 2, 4, 8, 16. So what's the fourth root of 16? 2. So 2's outside. X to the 11th is the same thing as x to the 8th times x to the 3rd. Do you agree with that? Right? I'd add the exponents. So what is the fourth root of x to the 8th? X squared. Good. Good. So I get x squared outside. And then what's left inside is the fourth root of x to the 3rd. Then I have plus. And 3x squared. 4x. There. So now does everything there appear to be like terms? I have an x squared. Good. I have the fourth root of x to the 3rd on both. Agree? So I can add these together. So 2 plus 3 is 5. Done. Yeah.
What would you do if it was like 3x to the 3rd? Would you still be able to combine?
No, the in the little house has to be the same. Has to be the same. Those have to be the same.
Okay.
So all the exponents, radicals, and all that have to be the same, but just say like terms. All right, pass them forward, please. Put your names, make sure your name's on them. I'm just worried about the front page.
Do we just rip it off? Do we just rip it off?
Yeah, you can just rip it off. You don't have to give me the whole packet.
So why does the world stop at like cubic? Why don't they make it like why didn't they say like
You call it quartic.
why don't we say
And
quartic?
quintic is fifth. And heptic or something like that. And heptictic.
Wait, so why don't we
And
actually say
doesn't matter. And then nonic, 9, so deca, or deca, and then
that? What's the 29th?
I know up to 12. Undeca, and then dodeca. All right, ready? Everyone have notes? Everyone good? The kid's late. She keeps leaving class, not passing notes. Everyone good now on notes? Okay. I'll come get them, I guess.
Are there factor keys included in this today?
Kind of. All right. So how many? You're looking for 2 of a kinds, 3 of a kinds, 4 of a kinds, 5 of a kinds. It keeps going. So that's all we're doing with that. So that's pretty simple. All right. So the math people out there, and I can only give you 2 places where this really matters at all. They don't like radicals and denominators. So the whole world of programming computers, They don't like radicals in the denominator. And the only reason I can figure that is because some math dork became a computer programmer, said we don't like this. And then also in calculus, they don't want to have radicals in denominators. It's just, but there's, no one can actually justify the reason that like goes further mathematically. It's like, you know, if you talk to someone who teaches BC calculus, there's like, oh, well, you can't have that because you want to make sure that the power rule works appropriately. Okay. After that, when does it matter? Oh, it doesn't. There's a dead end. Computer people. Oh, well, as long as you're using C++ and you're using, you know, gremlin programming, blah, blah, blah. Like, okay. Right. C++. All right. So needless to say, I need to figure out what to put on the bottom here and the top, and it's got to be the exact same thing, so I don't change. I don't take away from my fraction itself. So third root of x. X is not a perfect cube, right? But if I had x and x right here, which is x squared, and x here, if I'm multiplying these, so one on top, I'm going to get third root of x squared, and we're fine there. On bottom, what do I get? X, done. Okay, on problem number 2, I do have a fourth root that works with the x to the 5th, because I can say, hey, the fourth root of x to the 5th comes out as x, fourth root of x, which is fine. Or I can look at it and say, okay, what should I multiply to have 4 go into this number? And I would say, I'm going to multiply both top and bottom, both again by a fourth root, and I'm going to do x to the 3rd. Because if I do x to the 3rd, I'm adding the exponents, so that becomes x to the 8th. What is the fourth root of x to the 8th? X squared. Good. Question?
Yeah, just on the first one, why on the top did it change from x squared to just x in the answer?
Because I probably tried to write it and I forgot not to. Sorry. Thank you. All right. And then, so this one's fine. Then on top, I have 1 times this, so I have on top the fourth root of x to the 3rd. And that problem's done. I cannot reduce inside to outside, radicals outside to inside to radicals. Good so far? Yeah.
I'm just confused where you got the 3 from, like the x to the 3rd.
This right here, being it's the same on top and bottom, represents 1. So it's like we're getting a common denominator, but we're just rationalizing it. So think way back to fractions. 1 over 2 plus 1 over 4. What they teach you to do, multiply this by 2 over 2 to get 2 over 4 plus 1 over 4. So we're doing this step right here. That's all it is. But we're using x and radicals and other genius things that after BC Calc you'll never see. Yeah? Oh, because x to the 5th times x to the 3rd, I add the exponents, which gives me x to the 8th. X to the 8th is the perfect fourth root. Let's have that. Yeah?
So is it like not possible to just get x on the bottom?
Oh, I mean, in this case, no. We're stuck with the squared thing. I'm sorry. Get stuck with it. It's like, man, I got to hang out with the squares. All right, so this x squared's fine. It's happy. The third root of 4 is some irrational number, but what's a third root? Like 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8.
Wait, could you times it by a 4 then?
So I'm going to multiply this times that, and then I'm going to multiply this times this. So exact same thing, top and bottom. Yeah?
Couldn't you times it by a 4th and it would be 1? Like if you put 1/4 in this group, it would be 1.
Oh, then you're dealing with a fraction with a. Oh no, I guess. So yes, what you're saying, yes, I don't know if I would go with that curveball. If your mind thinks that way, you are a beautiful person and keep going. But the others around you would be like, dude, no. But I love you for having a beautiful mind. It's good to have that, okay? All right, so 1 times this, I'm just going to get third root of 2. Everyone okay with that? That x squared comes down. What is the third root of 8? 2. Done. What happened? People back there cussing now? It happens. It starts happening with math real easily. Yeah.
Why? Why did you
She's speaking.
why did you choose to do like the cube root of 2?
The reason I did that is if I multiplied 2 and that together, this right here, this portion of this problem becomes the third root of 8, which is equal to 2. That's why. 8's a perfect cube. Okay? And this is all stuff, this is totally normal for you guys to be going, wait, man, you're like getting angry. You might go and kick a puppy or something. It makes you normal.
I was going to say, I thought you demonstrate for us, and then you said that part, and then I was like, okay.
All right. Ready? So, this one you'll actually kind of like real well.
Oh, because
That's the answer.
Oh. Because 2 over 1.
So, if I take this right here and put it in exponent form, I get x to the 8 over 4, which reduces to that. And I got a 1 on top. You weren't the one that I was thinking I was going to say, wait, I thought you would have had it right. Sorry.
1 over x.
What do you got?
What's 1?
You got it, Tom?
Yeah, I got it.
No. 1.
All right.
Oh, I got that
1
one.
over x.
Does everyone see what I did?
Yeah.
So I converted this to exponent form. I had a, let's bring it down a little bit. 8 over 4 reduces to 2. So now we don't even have a radical because it reduced out. So I get 1 over x squared. That's a beautiful problem. You know, that's one of those you go give your mom a high five when you get home.
It's fun.
Okay. So we've gotten away from that for a little bit. We can kind of breathe a little easier. Express each radical in simplified form, rationalizing all the denominators. So here's the factor tree.
Not the
Yes,
staircase.
I'm ready.
128 is 2 times that, so that's 64. 2 times 32. 2 times 16. 2 times 8. 2 times 4. 2 times 2. 1, 2, 3, 4, 5, 6, 7. Oh, sweet.
Wait, I have a question.
Talk to me.
Did you give the factor tree to the other class today, and were they like flipping out?
They loved it. They applauded.
Did they
At the end of class, the bell rang. They
Uh-huh.
got me up on their shoulders.
Oh, yeah,
They marched me around school, chant,
Yeah.
stir up rules. Yeah, it was awesome.
I just like tried to keep the factor I'll take my payment in full.
2, 4, 8, 16. 2, 4, 6. 2, 4, 8, 16, 32, 64, 128.
You need to.
All right. Shh. We okay with that one? Okay, how many of a kind am I looking for?
3. 4x squared.
So every 3 of a kind is a perfect cube. So what comes outside? 2.
2x squared.
What comes outside?
It's 4x squared.
Oh, poor 2. That 2 has to stay inside. What comes outside?
X.
What comes outside?
X.
What's left inside? 2 and an x. Okay, so do the arithmetic. 2 times 2, 4. X squared. And then I get third root of 2x.
Oh, we're on factor trees.
That is so awesome.
All right, so the next one, maybe we can get away from a factor tree for a moment because there's square roots. So something that we should recognize on this one, the 2 times 3 is just going to give me 6. Is that okay? We're set there. Now underneath the radical, 63 is going to be 3 times 3 times 7, because 9 times 7 is 63. Are we good? Okay. And then 21 is the same thing as 3 times 7. Do you agree with that?
Yeah.
All right. So I'm looking for pairs. So square root of that is? Square root of that? 3. So 3 comes out. Square root of these 7s? Times 7. What's sticking around inside the radical? A 3. So then let's multiply this together. I got what? 42 times 3, 126. Is that right? Did I do that right? Someone help me.
I like to use
No? Yes? Might as well move on. No one's.
Wait, also
Is it right?
You're right.
Yay! Okay. All right. Problem number 7. I'm just going to make this for right now. Is everybody okay with that? So, x to the 11th isn't a perfect square, but if I take x to the 11th, I can make that x to the 10th times x. Agree? What's the square root of x to the 10th? X to the 5th, thank you. So I get x to the 5th, square root x stays as is, all over 4. Done. Say that one more time. Well, if it's an even number, because there's a 2 out here, because it's square root. So if it was a 3, I would make that x9 and x squared. Because like bases, when you multiply them, you add the exponents. All right, number 8, some of you might see this right away as this. And you're like, okay, cool, now what? Well, you can't have a radical downstairs. So what should we multiply the bottom and the top by? Root 10 works for me. So I get 3. Yeah. Up here. 3 root 10 over 10. Check to see if these outside reduce. They don't. I'm done. Hey, you guys, by the way, I love having bands in class. That was awesome. I'm sorry that just sucked.
Yeah, it's okay. You know you have to whisper during the free throw. Ride it just the ball leaving the fingertips. Under your breath. Jimmy Hoffa. And then they said every time you say it exactly right.
Got it.
That's according to time.
Happens. All right, here we go. All right. Look at this magical journey up here. You ready?
No.
Set. If you brush right by it, just smack your neighbor right across the... I'm just kidding. I'll start there. Is that okay?
Yes.
Is that okay so far? All right, now I have to recognize that 54, being that we're dealing with square root, is 9 times 6. Is that okay? That make sense? So the square root of 9 is 3. Square root of x, that is x squared, and then I have root 6. I'm going to pause for a minute because it's all of a sudden like some magical stuff just happened up there and we skipped it, right? Okay, so 9 times 6 is 54. So let's decipher this part by part. 9 times 6 is 54, yes? The square root of 9 is? 3. The root 6 stays behind. And then x to the 4th, I'm going to take half of it because that's a perfect square. That's where the x squared came from. We good so far? So now, I have 1 over 3. This doesn't really exist right now because we reduced it to here. But take a look here. We can make it look a little prettier because this 3 can cancel with this 3. Yes, I could have canceled it into the 27 instead, but I decided to leave it alone. So right here I got 1 over 1, thank goodness. And then I get x squared root 6 all over 27. The problem's done. So number 10, we might want to approach it. I don't know what I would need to multiply root 40 by in order to make, or third root 40 by to get it to be another perfect root. But let's just take this on the side as do you agree with that? Basically, 8 times 5 is 40. And what's special about third root of 8? 2. It's 2. So that means I'm going to have 2. This, and then 2, and then I have third root of 5. Okay, but you're like, you still have in the denominator. Yeah, you're right. But what can I multiply 5 by to make it a perfect cube? 25. Good.
Hold on. Oh, that's right.
Okay, that's the same thing as 1, right? So now on top of, we're going to get 60, third root of 25, over 5 times 25 is 125. Third root of 125 is 5. 5 times the 2 out front, 10. Reduce the 6 and 10, so I get 60 and 10. Done. Excuse me. Thank you.
Jeez.
These aren't that bad, are they? They're like, dude, these suck. Especially when I get home tonight and it's not moving around, and you're like, dude. And then you start yelling at your mom saying your teacher sucks. And we email my teacher, please. Can you email me out of class? I want to drop. I don't get all that many emails. I'll knock on article board on that.
My parents always email like once a night to one teacher and my sister. Like,
Alright, so for the email,
who will I yell at? My parents definitely have yelled at me.
Alright, ready?
Especially because like we feel bad for her.
Ready? So, just to show you more steps than you probably need to ever see. Is that okay? So that allows you to say that the top is this, the bottom is this. This is going to be the exact same thing we just did on the last one. Hold it down. Because we're recording, we have to make it look good. Act like I actually do teach. Yeah, third period, I got them scared. I haven't scared you guys yet.
What do you mean?
You kid and I have Drew Watson in that class. That kid barfed on friggin' another kid. He barfed on Ben.
Didn't Clay slump today?
Huh?
Didn't Clay fall asleep in class today?
He did. But he's almost getting over mumps, so.
Yeah. He does not have mumps.
I know.
Wait a second, so is that the
You spread that rumor through the whole school.
I did
He
not
has
spread
mumps.
any rumor.
Yes, you did. You were like, Clay has mumps. Like, no, he had staph infection.
Sounds better with mumps.
For 5 days.
Huh?
He got out of the hospital on New Year on Christmas Eve.
Holy cow.
I know.
Yeah?
It sucks.
If that's the class
I know, but like, he doesn't have mumps.
like the reaction.
No, it was during a test. Unfortunate.
What a
Unfortunate.
genius.
from viral?
Yeah. When did you
It's a shame that it wasn't
Huh?
like 8th period, so then 9th period just like.
Oh, he was there. All right, ready? Why did I go here?
You needed two
Is
X.
the Ken good? What does the bottom become? Yeah, it becomes third root of x cubed, which is the same thing as x. And then on top, I get 4x. And then I get the third root of x squared. Almost done. One last thing. What cancels? X. And it's this x here, and this x here cancels. So I get 4 third root of x squared.
They look fun when you do it.
It's because I have the magical board.
That messes up every day.
I will tell you that the one I have in the classroom down the hall is awesome. This one is like, dude, like they must have dropped this off the back of the truck or something.
Or maybe
Came in a damaged box. It was like sat in water for 4 months. All right, am I done?
One more.
One.
One more slide.
I'm sorry, but like he's gonna find out.
Or 3 more.
Wait, what?
Oh, okay. All right,
Not do
I
them.
can't.
sit down, put on your seatbelts, and hold on. We're gonna try something. All right, I'm actually gonna move forward a little bit.
Thank you.
Move forward. One that I'm looking for.
Can we be done?
Number 20 is actually the only one I'm looking for. Okay? So, if they are raised to the exact same exponent, okay? So they're both the third root. All I do on this one, this is the hardest problem you're going to see all day. You're going to make yourself cry yourself to sleep. Done. Whoa. But they have to be raised to the same fraction, okay? And that's it. All right, let's see. Number 19. I need to multiply by. Oh, wait, 25. Actually, what's wrong between these? So on this one, I can't do this right off the bat. All right. So if it's not matching up, then I have to say, okay, well, this is 5 to the 1/2 on top, and this is 5 to the 1/4. So we're actually going to do tug of war between top and bottom, which means we are subtracting fractions. Have I ever shown you my really cool way of subtracting fractions?
No.
See, what you do is you throw something.
That'd be cool.
Okay, ready? So, does everyone feel comfortable that this is the math that's up there?
Yes.
Okay, so we're going to get 5. So, ready? Ready? Minus 2 over 8 is 2 over 8, which is 1 over 4. What was the bigger fraction, top or bottom? Say top. So I get 5 to the 1/4 power. Now you have the rest of your night. You have the rest of your night figuring out how in the heck I subtracted fractions without getting a common denominator. It works with addition too.
You drew an X.
X and a dash and everything. So what I did is I really blanked out the. For those of you interested in the actual math behind it, it's A over B, and if I made it plus, and that's C over D, you'd make it A times D plus B times C over B times D. And it works with subtraction as well. You just change that to a subtraction. All right, so can you all figure out what the homework would be?
See,
It is going to be 8C even. Good with that?
When I used to care more, that's what I used to know.
I have a question.